calculation. It was just that you didn't see.
Human error.
Yeah, kind of human error, but it's also a rather subtle one because you don't do the calculation you don't need. They probably didn't do the calculation. What about the plastic in the bomb casing? How much would that contribute? That's obviously ridiculous to take into account. So where do you draw the line where you stop taking it into account?
And what was the percentage error on the LE?
I think it was at least 3 or 4 times bigger. So it had a horribly big fallout plume. There was a Japanese fishing boat in the area, so it became an international incident, especially since the Japanese, for understandable reason, were a bit touchy about American nuclear and stuff on it.
So then you have a question for the audience. Has anybody confessed having thinking about risks changed by anything they've heard today? Anything you thought, oh my goodness, yeah, this puts a different mind on things?
Well, it seems to me that you can use statistics and predict things which have happened in the past or in a closed system. But as soon as you start, from this talk, as soon as you start to extend that to a bigger system, it gets less and less useful. So if you're trying to, for example, predict the risk of a terrorist attack, it's perfectly useless because the biggest risk is actually those spikes which you can't predict. So statistics becomes useless in a big system.
Yeah, or at least in a system which is moving and changing.
Real world system.
Yeah.
Well, these spikes were quite scary on the graphs. I have to
Yes,
say.
they are. If you remember anything from this talk, I think it's those spikes. And that's just a simple power law, and they're all around us right this moment.
Elvira, you have a question?
Yes, I think there is a major problem in communication, and where statistics become absolutely useless because we know what's going on in Europe, maybe US. We have no idea what's going on in the other parts of the world. And there are many examples like this, like with the break of Eastern Bloc and the Chernobyl catastrophe and etc. People here probably couldn't predict it, but people there knew it very well. And what is a surprise for us?
So insufficient data, basically.
I'd be more worried about the
we don't have a data for the global things.
I mean, as far as I can tell, what they were doing at Chernobyl was turning the safety systems off so that they could demonstrate it would work without the safety systems.
Yeah.
So one would ideally prefer systems to prevent them from doing that.
The reactor design had what's called positive void coefficient as well. Fundamentally, losing coolant made the actual power output rise rather than fall. Our systems actually use the water as heavy water actually used as the moderator, as well as the coolant. So if they lose coolant, they actually shut down and basically get fast neutrons.
So to summarise that point, although we might have some legitimate worries about the risks in the EU and in the United States and Canada and so on, there might be worse risks from countries which have got different kind of democratic oversight, such as picking some countries at random, China or Iran. So the Supreme Leader might have his own view as to what's tolerable and what's not tolerable.
The SARS epidemic is a great example. One of the big problems was that the Chinese administration didn't like giving out information, especially about something that was slightly embarrassing and that its citizens could get sick. And given that you have an administration that thinks it's embarrassing that citizens can get sick, that's already a bit of a problem, of course. On the other hand, China and Indonesia seem to actually learn quite a lot from the SARS experience. But it seems to suggest that we should work actually quite a lot to develop better monitoring systems. It's actually rather interesting. I vividly remember Chernobyl disaster because I was home from school that day with a bit of a cold. So I was sitting playing with my computer and listening to radio. And then the first radio report came in that there had been an alarm at the Forsmark nuclear power plant north of Stockholm, which of course perked my interest. So I was listening into the news stories as they developed, and it started to sound like there had been some kind of accident at Forsmark, but nobody really knew what was wrong. And eventually they started to realize, okay, it's our external radioactivity detectors that are going off, not the internal one. It's not us. Yeah. So over the span of a day, it kind of developed the situation. But that was actually the first detection of Chernobyl outside the Soviet Union at the time. It was at that power plant because their safety system reacted to it. It took, I think, 2 days before finally the Soviets admitted, okay, yes, it was there. You have a satellite photos now. Okay, let's admit it. But I think in some disasters, well, you can probably accept that it takes time. But for many of the high-tech disasters, where I think we're especially worried about, we probably need monitoring that is much quicker.
Anders, if you, let's take a biological approach. If you have monitoring systems, you're effectively providing an immune system to that. And with any immune system, you can get autoimmune disease. In that case, what you described is the autoimmune reaction. You know, if they'd taken action to shut down the reactor or something similar.
I actually think we even did that. They temporarily shut down the Forsmark reactor, just in case. But autoimmune, it's a balance. About 1 kilogram of your body is actually immune system, which is, when you think about it, an amazing thing. Because normally we think of white blood cells as well, microscopic, nothing, but all the immune cells and the lymph and the antibody, it's an enormous amount, and it's actually metabolically very expensive. But we're still carrying around almost 1% of our bodies just as immune system. And when you think about modern computers, how much is firewalls, antiviral software and so on? I think it's more than 1% of the performance is actually right now used on that. And we're probably going to need that for other things. Smartphones is a great example. MMS viruses and Bluetooth viruses is something that we're probably going to see in a few years as a pretty sizable.
Just a minute. Mike, did you have a question?
Oh, I was just going to make the point I like the debate unknown knowns being sort of equated with competent bias. I haven't heard that interpretation before. I presume Rumsfeld didn't actually say that.
No, he didn't. It was Slavoj Zizek, the leftish philosopher, who pointed it out later. I've seen it in other sources too, because it's pretty obvious asymmetry actually. But Zizek, of course, especially liked to point out, and it was Rumsfeld who was suffering from the biggest one. And I think it's an interesting problem, because our biases are going to mean that we're going to misallocate resources for disasters, even when we're trying to make a more rational one. We should be preparing that we're going to make a few rather serious mistakes here too. So we probably need to think about how to do robust action here.
The bit I was just going to finish saying was that 2 or 3 days ago there was a report in the news about the monitoring for after the SARS and that, they put body heat monitors into airports to catch people who had elevated temperatures.
Ah, yes.
And they were saying in the news there was apparently a couple of cases of H1N1 got past this system, and there were things, and basically it blamed the people for taking antipyretics, basically paracetamol, to drop their body temperature.
The question is whether we did that to get past these sensors or just because we felt
but they were doing it anyway, so the idea is the monitoring system ends up being worse than the disease.
Yeah, sometimes it depends a bit on what the monitoring system is for. So for example, the mortality monitoring system that's developed as a kind of response to epidemics, it's also pretty useful for figuring out a lot of the other causes of death, including getting hints about some correlations. For example, that smoking is bad for you. That took quite a while to determine, and that was done using a lot of epidemiological data eventually. That was when we were proving. So I think autoimmune issues, yes, they exist and they need to be careful. But you can also use some of these monitoring systems for other things. The Shinkansen seismology system, for example, well, that's wonderful funding also for a good seismology system for Japan, funded partially by Japanese railways. So I think we can actually find ways of reusing. So maybe we should, instead of saying that it was a failure that they took paracetamol, well, maybe you should actually put more of these sensors around a bit randomly instead and see how many people have not taken their paracetamol or their antivirals.
I wasn't, it was just the statement that basically you have to ask the question whether, you know, do you behave differently if you're being watched, kind of thing, and if you're actively doing it.
Oh yes. That's actually a subject for another interesting talk, I guess. If you think about transparency and surveillance and issues like that, that would be fun.
Just before we wind up, anybody who hasn't spoken much yet, Adam, if you want to ask a question?
If we have some statistical data on, say, the probability that I'll get hit by a car, if I stop, look and listen every single time across the road, then aren't I exempt from that law? I mean, what I'm talking about here is the whole immortalist argument. If you can survive from 1 second to the next, then aren't the probabilities that I'll get killed each second multiplied? They're not multiplied together. If you can manage to survive for 1 second and then for the next, this is the whole argument that a mortal can exist. That you can survive.
I'm not certain I follow your argument. Are you thinking something like quantum immortality?
No, if let's say you can calculate the probability that you can live for 10,000 years.
Yeah.
If you take care